Hello, my name is Nofatin Fatimi. My matrix number is 231110979. Okay, I will explain about question 1, A and B. First question is explain what is the difference between gauge pressure and absolute pressure. So my answer is gauge pressure is measured relative to atmospheric pressure, while absolute pressure includes atmospheric pressure as a reference point. Gauge pressure become 0 at atmospheric pressure, whereas absolute pressure is measured from a complete vacuum. The next question asks, show pressure exerted on several points under the given fluids, which underlies on the same horizontal line. Position of Pi is same in horizontal line with pH. However, given that pressure H is not the same as pressure I, explain what caused the inequality of this pressure using your own dimension. So my answer is the difference between this pressure pH and Pi are caused by the difference of density of fluids they are submerged in. Pressure will be bigger when the higher the density. I also include some calculation to show that there's a pressure difference between these two fluids. First, fluids are using mercury, and the other fluids are using water as the medium. So it shows that the pressure is higher because of mercury density is higher than the water density. Next, for question 2A1, is to determine the tension in the rope of the crane when the concrete block is suspended in the air. So my calculation is, first I find the volume. Using the formula height times length times width. So 0.4 times 0.4 times 3, I get 0.48 meter cubes. And then I insert it in the formula rho GV to find the tensions. And I get 10.8 kilonewton. Then for question 2, A2 is to determine the tension in the rope when the concrete block is completely immersed in water. So for this question, we have to change the density because we are using the density of water now. Okay, so I use the density of water 1.1025, and I use the formula for buoyant force, which is rho GV, and I get 4.8 kilonewton. After that, I just minus the earlier answers for A1, which is the tension force earlier, and then I minus with the buoyant force I find in question 2, and I get 6 kilonewton for the tensions inside when the concrete is inside the water.